we will derive an equation to make a particular lens, and that equation is also called as lens maker's formula. I can derive lens maker's formula using a relation between refractive index, object distance, image distance, and radius of curvature, that's n2 by v minus n1 by u, which is equal to n2 minus n1 by r. Using this, I can derive a lens maker's formula, that is 1 by f is equal to n21 minus 1 into 1 by r1 minus 1 by r2. So it's a lens maker's formula. It gives the relation between focal length, refractive index of second medium with respect to first, radius of curvature of two surfaces. How to derive this equation? First, what I will do, I'll consider a convex lens. So it's a convex lens and it's a principal axis. It has two surfaces. Let it be A, B, C, and this surface, let it be ADC. And let this point be the optical center of this particular lens. I'll consider an object O at a distance of u from the optical center of the lens in a medium where refractive index is n1 and refractive index of this lens be n2. And again here the refractive index will be n1. Light ray from this object without any reflection and refraction, it passes through the principal axis. I need two rays to get the image. One more ray, it strikes the surface ABC at a point M, this point. Immediately it refracts. You know this, when light travels from rarer to denser, it bends towards the normal. And again, this refracted ray, it strikes the surface at the point N and it refracts. These two rays will meet at the point I, where I can see the image of the object. But the formation of image, actually it is of two steps. First one, in the presence of this ABC, means in the absence of the second surface ADC. Second one, in the presence of ADC. First I will consider the surface ABC in the absence of the second surface. First step, in the presence of ABC, I will consider only the first surface, that is ABC. It's an object, it's a first incident ray. Object distance is u, and this ray, it strikes at the point M refracts and it gives an image I dash, which is at a distance of V dash. And I can draw a normal. It always passes to the center of curvature. Now you can apply this equation. N2 by V minus N1 by U is equal to N2 minus N1 by R. See here, N2 is the refractive index of the second surface or second medium, and N1 is the refractive index of the first medium. But here the only one change, instead of V we have V dash, and instead of R I can write it as R1, radius of curvature of this first surface. It means it will be N2 by V dash minus N1 by U, which is equal to N2 minus N1 by R1. Observe this carefully. In the absence of second surface ADC, we have an image called I dash at a distance of V dash. So N2 by V dash, that is image distance, minus N1 by U is equal to N2 minus N1 by R1. In the presence of second surface, that is ADC, this is ADC. In the presence of second surface means if you say lens, there will be two surfaces. Because of the first surface, image is I dash. We are not going to place any image inside the lens, but this image I dash, it acts as a virtual object for the second surface. So image I dash, it's a virtual object for the second surface ADC. So this will be your I dash. Due to the presence of ADC, it refracts, and here I can see the image I. Now this will be the object distance, because whatever the image formed due to the first surface acts as a virtual object for the second surface. So this is U and this will be V. Here instead of N1, this is N2 and this is N1. Now observe this. We have the standard equation N2 by V minus N1 by U is equal to N2 minus N1 by R. Instead of N2 we have N1, that is N1 by image distance is V only, it is V minus, instead of N1 it is N2 divided by U is our image distance, that is V dash, image distance in the first surface. I'll write V dash, which is equal to N2 is nothing but N1 minus N2 by R2. So it's an equation number 2. I'll write N1 by V minus N2 by V dash, which is equal to, for the simplification purpose, I'll take negative sign outside of this. It will be minus of N2 minus N1 by R2. From the first surface, N2 by V dash minus N1 by U is equal to N2 minus N1 by R1. Due to the presence of second surface, N1 by V minus n2 by v dash is equal to minus of n2 minus n1 by r2. You can say it's an equation number 4. Now, if you add these two equations, 3 plus 4, n1 by v minus n2 by v dash plus n2 by v dash minus n1 by u, means you can cancel these two, is equal to n2 minus n1 you can take common. You will be getting 1 by r1 minus 1 by r2. Say this, n1 by v minus n2 by v dash plus n2 by v dash minus n1 by u is equal to n2 minus n1 into 1 by r1 minus 1 by r2. I can cancel these two terms. It means n1 into 1 by v minus 1 by u is equal to n2 minus n1 into 1 by r1 minus 1 by r2. n1 into 1 by v minus 1 by u, it is 1 by f, Lenz's formula, which is equal to n2 minus n1 into 1 by r1 minus 1 by r2. Send this n1 to here in RHS. 1 by f is equal to, n2 by n1, I can write n2 1, refractive index of second medium with respect to first, minus n1 by n1 is 1 into 1 by r1 minus 1 by r2. This equation is called Lenz-Maker's formula.